right, welcome ladies and gentlemen to our third lesson in our study of logarithms and exponential functions. Today we're going to be looking at the logarithmic function, and this is going to be video 1 of 2. The first video is going to look at what is a logarithm, and the second video is going to figure out how to graph a logarithm. So let's start with what is it? So it is what's called the inverse of the exponential function, which means it's just the function that undoes exponentiation. Another place that we've dealt with this is undoing the square, which means we take the square root. Likewise, when we add in order to undo subtraction, or divide to undo multiplication, they're things that undo each other. And that kind of senses that we're trying to solve equations, which is coming up in a few lessons. But right now we want to figure out what does it look like and what we're going to do with it. So as a definition, this is what the logarithm looks like. When we have y equals b to the power of x, we know that b is our base of our exponent, which means b is going to be the base of our logarithm. So y equals b to the x can be written as log base b of y is equal to x. So you notice the exponent is off here by itself. Basically, we've undone exponentiation because we don't have an exponential function anymore, and the exponent is in the main line. It's not in the exponent anymore. All right, so what does that look like with numbers? If we were to take 4, let's not do 4. 4 is not a good number. Let's do 8 is equal to 2 to the 3rd power. We can rewrite this in logarithmic form, essentially undoing the exponentiation by saying log base 2, because that's the base of our exponential, so log base 2 of the opposite side of the equal sign is 8 is equal to the exponent, which is 3. So one way we can think of this is 2 to the 3rd power is equal to 8. Likewise, log base 2 of 8 is equal to 3. And we used to make those kind of statements back when we looked at the square root of 16 is equal to 4, because 4 squared is equal to 16. It's this kind of statement. They're equivalent statements in two different forms. One in the square root form, one is in the squared form. So we could say things like this: 25 is equal to 5 squared, but as a logarithm, we could say this is log base 5, because the exponent is base 5, of 2. Oh, sorry, not of 2. Log base 5 of 25 is equal to 2. And we can make all sorts of statements like this. So what are we going to do with them? It's a good question. So we're going to be doing that right there. We're going to be swapping them from logarithms to exponentials. We're going to write logarithms in exponential form. We're going to write exponential functions in logarithmic form. And we're going to be evaluating logarithms. So what is that going to look like in all three forms? Wish that had something to do. So the first one, a logarithm in exponential form. So if I had log base 3 of 81 is equal to 4, I'm going to rewrite that as an exponent, going in the same way that we did in the last slide. The base is 3, so 3 to the power of 4 is equal to 81. And that is a true statement. 3 to the 4th power is 81. And the logarithm base 3 of 81 is equal to 4. We're going to rewrite exponential equations into logarithmic form. So we're going to be taking, let's say, 6 to the power of 3 is equal to 216. And we're going to be rewriting that in logarithmic form, saying log with the base 6, because the exponent is base 6, of 216 is equal to 3. And lastly, we're going to be evaluating logarithms. And evaluating means find the answers. So if we said log base 3 of 9, what does that equal? So we're going to say that equals to x. And what we're going to be doing to solve this is usually, and this doesn't always have to be done, we're going to be writing them as exponential numbers or exponential form because that makes more sense to most of us. So we're going to say this is 3 to the power of x is equal to 9. And we know that 9 is equal to 3 squared. So that means x is 2. So for right now, they're going to be numbers that should be very familiar to us. Log base 2 of 16 is equal to x. So we're going to evaluate. Now, what I want to point out is normally it says log base 2 of 16. We need to evaluate it. So we're going to say we don't know what it equals to. So we're going to rewrite it in exponential form. And right now, we should be able to do these in our head. 2 to the power of 4 is equal to 16, and therefore x is 4. All right, so they should be pretty easy numbers when we are looking at these type of problems. The last thing that you need to know in this video is what's called the common logarithm. The logarithm that you see on your calculator as log. So you'll see this as a button on your calculator, LOG. Log is log base 10. So it would be log base 10 of something. And log base 10 is pretty nice. We actually work in a base 10 system. I hope you guys can all figure this kind of thing out here. If we had log base 10 of 100, we're really asking 10 to the power of what is equal to 100? And we know that to be 2. And we should be able to do quite large numbers here. If we said, actually, I'm not going to write it like that because when it's log with no number as a base, we understand that to be log base 10. All right, so if there's no number as a base, that is automatically log base 10. So what this is saying right here in this question is 10 to what power is equal to 10,000. And you should know that the number of zeros is the exponent on the 10. So since there are 4 zeros, this is 4. All right, that's a very straightforward video on how to or what is a logarithm. There's lots more that we're going to be learning. I want you to remember to watch part 2 of this on how to graph a logarithm. And I hope to see you guys there. I'll see you guys later.